Again, welcome to DSRT 734 class. In these lectures, we're going to cover the measures of variations. So our main objective is to determine the range of a data set. We're also going to learn how to determine the variance and the standard deviation of a population and also of a sample. We're also going to use the empirical rule and Chebyshev's theorem to interpret the standard deviation. So first we start with the range. Now the range will be the difference between the maximum and the minimum data entry in the set. And the main reason why we measure the variation of a data set is to learn or is to know if the values are very close or they are widely spread. What I mean by that, for example, if we have a data set and our values are the same and we have 20 values, this means the range will be 0. Because let's say the 20 data set each is 15. So to find the range, the maximum value is 15, the minimum value also is 15. Now the same thing applies to the variance and the standard deviation. All the values will be 0. Now if the standard deviation or the variance value is very small, it means the values are very close to each other. And if it's bigger, it means they are widely spread away. So now the difference between the maximum and the minimum data entries will give us the range. So this means the data must be a quantitative, since we are going to find the difference of it. And the formula is the maximum data entry minus the minimum data entry. So we have an example here. A corporation hired 10 graduates. The starting salary for each graduate are shown below. We should find the range of the starting salaries. So we look at the 10 salaries values. We are going to find the difference between the maximum and the minimum salary, and that will give us the range. So here we put the data in order from lowest to the highest, which is ascending order. So this means the minimum value is 37 and the maximum value is 47. So the difference of 47 and 37 will give us the range. So the range of the starting salary will be $10,000. Next, we're going to learn what is a deviation, variance, and also standard deviation. So a deviation normally will be the difference between each data entry and also the mean of the data set. So the formula will be deviation of x is the x value minus the mean. Here we are using the population data set. So it will be the value minus the population mean. Now if it's a sample data set, then it will be the x value minus the sample mean. And that will give us the deviation. So here we have the same example. A corporation hired 10 graduates. And this is their starting salaries for all the 10 graduates. Our goal here is to find the deviation of the starting salaries. So this means the first thing I'm going to do is to find the mean of the 10 starting salaries. Then we are going to subtract the mean from each starting salary, and that will give us the deviation for each value. So first we find the mean. We add all the values and divide it by 10. That is the number of data entries. And that gives us 41.5. Now we have to subtract 41.5 from each starting salary. And normally, the total deviation of the data set will give us 0, because we know that some of the values will be less than the mean and some of the values will be greater than the mean. So the difference of the two will give us 0. This is the reason why when we are looking for standard deviation, we are going to square each deviation. So 41 minus 41.5, I'm going to square the value. All the values square, so that if our answer is negative 3.5, the square of negative 3.5 will turn to a positive value. Then when we get total, we find the square root of it, and that gives us the standard deviation. So again, here we are finding the deviation. And as we said, to find a deviation of a data set, first we find the mean of the data set. Then we subtract the mean from each value of the data set to get a deviation. And always the total deviation is 0. Next, we learn how to find the variance. So the variance will be the difference of each value and the mean, all square. So we call this the sum of squares, because we can see we sum each. So example of the 10 starting salaries, we are going to find the deviation square. So when we find a deviation, we square it for each, then we add all together, then we divide by the size of the population. Now, if it's a sample, it's the same concept also. So the square, now, if you find a variance, to find the standard deviation is the square root of the variance. Now, with the sample, we are going to do -1. But let's go through the steps for the population variance and also the standard deviation. So first thing we do, as we said, find the mean of the population data set. Then we are going to find the deviation of each entry, which means we subtract the mean, population mean, from each value. Then after that, we are going to square. So this will be square each deviation. Then we are going to add to get the sum of the squares. When we square each deviation of the data set, we add all of them. Then that gives us the sum of squares. Then after that, we are going to divide by the population size, and that will give us the variance. Then the square root of the variance will give us the population standard deviation. So let's use the same example here. We have 10 graduates with their 10 starting salaries. This time we are going to find the population variance and also the standard deviation of the starting salaries. So we already find the mean to be 41.5 in our previous slice. We had all the values divided by 10, and that gives us 41.5. So now we are going to find the variance first, subtract the mean from each value, then we square. So the deviation will be our second column. We subtract the mean from each value. Then we square each deviation. The goal here is that, for example, we have -0.5 here. When I square -0.5, it gives me a positive value, 0.25. So we can see that on the square of each deviation, all the values are positive. Then we sum all, and that gives us the SS, sum of squares of X. Now, after that, to find the variance, we divide by the population size. So that gives us 8.9. Then to find the standard deviation, we are going to find the square root of the variance. So the standard deviation will give us 3.0, square root of the variance of 8.85. So this means the population standard deviation is about $3,000. Next, we are going to do the sample variance. Now, the difference of the formula is that instead of dividing by the sample size, we divide by the sample size -1. Then all the steps are the same. We find the square root of the variance. So first, again, we find the mean of the sample data set. Then we find the deviation of each entry. Then we find the square deviation for each entry. Then we add to get a sum of squares. Then to find again the sample variance, we divide by n-1. Then to find the standard deviation, it will be the square root of the variance. So we are doing the same example. We have again 10 starting salaries. This time we want to find the sample standard deviation. So we are assuming this time the data set here is a sample. So we follow the same process. We find the deviation. First, we get the mean of the data set. Then we can find the deviation of each entry. Then we square the deviation. Then after that, we find the variance. But this time, the variance will be divided by n minus 1. So we get 9.8. Then after that, we find the standard deviation, which will be the square root of the variance. Now, using technology to find the standard deviation, we can use either Microsoft Excel and or any statistics programs such as SPSS or JSP, etc. So here we have an office rental rate data set here. We say we have a sample office rental rate in dollars per square foot per year. This is for Miami Central Business District. And the data is shown below. Now, the reason why we are using technology for this is because the values are too many. To do this manually, it's possible we can do it, but it will take more time. So either we can use a calculator or a computer. A very simple computer will be Excel. So here we decided to use a Minitab. So we plug in our data into the system. We select descriptive statistics. For example, we can find the mean, media, standard deviation, which is what we are looking for. Also, you can give us the minimum and maximum value. We can also find the Q1, Q3, because Q2 is the same as the median. Now, how do we interpret standard deviation? We said the standard deviation is the measure of a typical amount an entry deviates from the mean. So the more the entries are spread out, we say the greater the standard deviation. Now, if the values are very close, then the standard deviation value will be lower. So we can see example here, we have a data value. All the values are in the same number 5. All the values are 5. So we can see here the standard deviation is 0. Now we can see here the data a little bit spread in a normal distribution. Standard deviation is 1.2. But when it's widely spread, we can see the standard deviation go up 3.0. So next, how do we interpret the standard deviation empirical rule using the 68, 95, and 99.7 rule? So 68 will give us 1 standard deviation, 95 2 standard deviation, then 99.7 will give us 3 standard deviation. We will cover this more in probability distribution concept. So here we say for data with a symmetric bell-shaped distribution, which is a normal distribution, the standard deviation has the following characteristics. That's if the distribution is normal distribution. So we say about 68% of the data lie within 1 standard deviation of the mean. Then 95% of the data will lie within 2 standard deviations of the mean. Then 99.7% of the data will lie within 3 standard deviations of the mean. And this is our normal distribution bell-shaped curve. That's the bell-shaped curve. Now in the middle is our mean. Now we can see to the right, we had 1 standard deviation, 2 standard deviation, 3 standard. This means in the blue area will be the 68%, 1 standard deviation. Then the next brown area from plus and minus 2 standard deviation, S stand for the standard deviation, will be 95% of the distribution. Then the green section will be plus and minus the mean, 3 standard deviation, the mean, plus and minus, and that gives us 99.7. So again, that's 34, 34. Then we have 13.5, 13.5 with 34, 34 together will give us 95%. then roughly the data is 99.7%, which will be our 3 standard deviation plus or minus the mean. So let's see this example. Here we said a survey conducted by the National Center for Health Statistics. The sample mean height of women in United States between the ages of 20 to 29 was 64 inches, with a sample standard deviation of 2.71 inches. Here they say we should estimate the percent of the women whose heights are between 64 inches and 69.42 inches. Now, most of the values we need as given to us. We have the mean, we also have the standard deviation. So it will look something like this. Remember, our mean is 64 inches. The mean height of the women is 64 inches. So we have 64 inches. Then we have the standard deviation to be 2.71. So this means the standard deviation from the mean and also the standard deviation plus the mean. The 1 standard deviation. Now, 2 standard deviation will be 2 times. Let's see the value again. The standard deviation is 2.71 and the mean. So the first section, we give a 64 minus 2.71 to 64 plus 271. 2 standard deviation will be 64 minus 2 times 2.71 to 64 plus 2 times 71. Then we have the 3. So that's what we came up with these values. 64 is here. 64 from the standard deviation. 1 standard deviation will give me 61.29. 2 standard deviation from it will give me 58.58. Then 3 standard deviation will give me 55.87. Now to the right, we are going to add 1 standard deviation. So 64 plus 2.71 will give me 66.71. Then I will multiply 2 by 2.71. The answer I get, I will add it to 64. And that will give me 69.42 because it's 2 standard deviation. The same thing, I will multiply 3 by the standard deviation. So 3 times 2.71 plus the mean, which is 64, will give me 72.13. So here we say 34% plus 13.5% will give me 47.5%, which is the shaded area here. So here we say of women are between 64 and 69.42 inches. So in our distribution of data, based on what we just calculated, we can say that 47.5% of the women are between the height of 64 inches to 69.42 inches. Next, we're going to cover the Chebychev's theorem. And what this theorem said is that the portion of any data set lying within K, the K is the normal standard deviation, lying within the K standard deviation, whereby the standard deviation will be greater than 1, which means K is greater than 1 of the mean, is at least 1 minus 1 over K squared. Again, this is a theory, this is a formula. So here, for example, if K equal to 2, then in any data set, at least we have 1 minus 1 over 2 squared, which gives us 3/4 or 75%. So here we may say that 75% of the data lie within 2 standard deviation because K equal to 2. Now in our previous example, we have 3 rows and 3, 68, then we have 95, then we have 99.7. Let's go back. 68 is 1 standard deviation, 95% is 2 standard deviation, then 3 standard deviation is 99.7. This is the standard for normal distribution. But here the Chebyshev gave us this theorem. Chebychev's theorem say 1 minus 1 over k squared if only k greater than 1. So if k is 2, we say 75% of the data will lie within 2 standard deviation because k is 2. Now if k is 3, we will get 1 minus 1 over 9, and whatever answer we get will be the percentage, and which is right here, 1 minus 1 over 3 squared, which gives us 8 over 9, and that gives us 88.9%. So we said that in any data set, at least 1 minus 1 over 3 squared, which is give us 88.9% of the data will lie within 3 standard deviation. But we saw that with the normal distribution, in a 3 standard deviation, we came up with 99.7%. So let's see an example with the Chebychev's theorem here. Here we have an age distribution for Florida, which is shown in the histogram given. And here they say we should apply the Chebychev's theorem to the data using k equal to 2, which is 2 standard deviation. What can you conclude? Again, this is the graph given. Horizontal, we have the age in years, and vertically, we have the population in thousands. And the data set mean is 39.2. The standard deviation is given to be 24.8. So the first thing we're going to do, since we know k equal to 2, then we're going to get mean minus 2 standard deviation, which the mean is given to be 39.2, minus 2 times the standard deviation is given to be 24.8. So that gives us negative 10.4. Here we say we are using 0 since age cannot be a negative value. So this is negative 10.4, we use 0. Then mean plus 2 standard deviation will be 39.2 plus 2 times the standard deviation 24.8, and that gives us 88.8. So since this is 2 standard deviation, 1 minus 1 over 2 squared gives us 75%. So here we can see at least 75% of the population of Florida is between, since we have negative value here, age cannot be negative, so we start from 0. So we say it's between 0 to 88.8 years. So next is the standard deviation for group data. So we can see the formula also is the same as the regular standard deviation, but since we have a group data, the group data will be based on the F, the frequency, how many times each data in a group occurs. So this means the sample size then will be the sum of the frequency, because F will represent the number of entries in the data set. So here we say when a frequency distribution has classes, we need to estimate the sample mean and also the standard deviation by using the midpoint of each class. So example given here, we should find the standard deviation for a group data. So here we can see we have a lot of data, say 50 household, but some of the values are the same. So we are going to group them together. So for example, 1, if we have 10 ones, then in ones, the F will be 10. If in 2 we have 4, then with 2, F will be 4. So here we collect this data set, and now we are going to find the sample mean and also the sample standard deviation of the data set. So first we construct our frequency distribution, category from 0 to 6. We count each, and that will be our F here, will be our grouping for each category. So to find the mean, we had each value, but this time we have the frequency. So we can see within X0, we have 10. When S is 2, we have 7, 3 is 7. So we need to do the multiplication here. So first we have 0 times 10 is 0. Then we have 1 times 19. Then 2 times 7, 3 times 7, we had all these values. This will be the sum of all the data sets. Then we divide it by n, the sample size. And that will give us, again, the sample mean. So here we say the sample mean is 1.8 because we divide 91 by 50, and that gives us 1.8. Now, to find the standard deviation, remember we need to find a deviation for each entry. So we subtract the mean from each entry data set. Then we square, deviation square. Then we can sum it. But before that, since in each category here, we have different amount of values. So you can see within zeros, we have 10. When the S is 1, we have 19. 7, 7, 2, 9. So we multiply by each deviation value. And that's the formula here. Multiply the number of tally or the frequency by each deviation square. So here we square the deviation before we multiply by each frequency of that category. And that gave us 145.40. Next, we want to find the standard deviation. So we divide 145.40. This is a sample data set, so it will be 50 minus 1. Then we find the square root of it. And that gives us the standard deviation is about 1.7. So this will be the conclusion of our lectures. Again, these lectures gave us the idea of, again, finding So again, that will be the conclusion. Hopefully, in our next lectures, we are going to learn how to find the positions of a data set like Q1, Q2, and Q3. Here we learn again how to find the standard deviations and also how to find the variance, range. The whole idea is measuring of a variation. So again, thank you.